All right, so checking out problem 16, it's a trig equation it's asking us to solve. We didn't get into a whole lot of trig equations in pre-calc last year, but I'll just walk you through how to solve this one. So it's asking us to solve 3 sine squared of x equals cosine squared of x on the interval where x is between 0 and 2 pi. So this interval is kind of important because really a trig equation could have an infinite number of solutions because we're solving for an angle here, and really you could just keep going around the unit circle over and over again, and you could get an infinite number of solutions if you're looking for a specific angle. So we're usually going to limit the domain here between 0 and 2 pi so that we're only getting solutions one time around the unit circle. So in order to solve this, we're going to need to know a few trig identities. The first one being that sine of x over cosine of x equals tangent of x. And really that's the main one we're going to use here. So if I'm solving 3 sine squared of x equals cosine squared of x, I don't really want to have two different trig functions in this equation. It's going to make it a lot harder to solve. So I want to try to use this identity to change the sine and cosine into just a tangent. So the way I'm going to do that is divide both sides by cosine squared of x. So when I do that, the right-hand side, cosine squared of x over cosine squared of x, is just 1. And then the left-hand side, well, that 3 is just going to stay, and then it's sine squared of x over cosine squared of x. Well, that will become tangent squared of x. So now I've gone from 2 trig functions to just 1, and then I'm going to try to just get tangent of x instead of tangent squared. So let's move this 3 away from it. Let's divide both sides by 3. So tangent squared of x equals 1/3. And then to make it just tangent instead of tangent squared, let's take the square root of both sides. So then we'll be left with tangent of x equals, let's see, square root of a fraction, we just split it up. The square root of 1 is 1. We can't simplify the square root of 3. So tangent of x equals 1 over the square root of 3, or if we rationalize the denominator, that would be the square root of 3 over 3. Now, if we know our unit circle, we might just know where those tangent points exist. Where is the tangent equal to the square root of 3 over 3? But you know, we might not have tangent values memorized, or we might have forgotten them if we did last year. So we need to still be able to find those. So I'm going to use my unit circle page, and really what I'm looking for are points where the coordinates are square root of 3 over 2, 1/2, either positive or negative. And I want these points specifically because, remember, tangent is sine over cosine. Sine is the y coordinate, cosine is the x coordinate. So if I have 1/2 divided by square root of 3 over 2, when I multiply by the reciprocal, that's going to be 2 over square root of 3. 2's will cancel out. And so this would equal 1 over the square root of 3, which is what we're looking for. So at any points with these coordinates, the tangent will be 1 over the square root of 3. So we can look on our unit circle page. We can figure out that the tangent is equal to 1 over the square root of 3, or the square root of 3 over 3, when x is equal to pi over 6, has coordinates of square root of 3 over 2, 1/2. 5 pi over 6 would have coordinates of negative square root of 3 over 2, 1/2. 7 pi over 6 would have these coordinates with both of them negative, and 11 pi over 6 would have those coordinates with the 1/2 being negative. So at any of these points, the tangent would be 1 over the square root of 3. And really the positive or negative doesn't matter a whole lot in the equation because in the original equation, both the sine and the cosine were squared, so they're going to come out positive anyway. So these 4 points would make this equation true.